Hi students, I'm Sai Shri. The topic of discussion today is chemical equations. It comes under the chapter chemical reactions and equations. Before we enter into the topic of chemical equations, let us know about chemical changes. The matter which is surrounding us will undergo physical and chemical changes. The physical changes actually affect the chemical nature and not the chemical composition. For example, you take water and you melt it at low temperatures, it converts into a form of ice. And once again, you heat that ice, it converts into form of water. That is, physical changes are reversible in nature. But the combination of substances to form a new substance is termed as a chemical change. If you take chemical changes, the new substance which is actually formed cannot be reversed into its original form. So, chemical changes are irreversible in nature. Whenever chemical change occurs in matters, we consider as chemical reaction has taken place. If you see the example which I have given in everyday life, you take an example of photosynthesis. Photosynthesis is a chemical reaction wherein the carbon dioxide and the water is present. This photosynthesis reaction takes place with the help of chlorophyll and the sunlight and converts into glucose and oxygen for the living of these plants. If you take cooking process, by heating, the vegetables or the cooking materials undergo chemical reactions and we get delicious food. If you take this example of rust, rust is also the product of a chemical reaction. You have steel materials which are exposed to atmosphere, and because of this reason, this chemical reaction takes place. So, chemical reactions actually takes place in our everyday life in n number of situations. So, the symbolic representation of the chemical reactions are termed as chemical equations. We have seen about chemical changes, chemical reactions, and chemical equations. So, how to find out that a chemical reaction has taken place? So, if a chemical reaction is taking place, there will be a change of state. That is, the state, for example, if it is in a solid state, it can go into a liquid state. If it is in a form of a solid state, it can go into a form of another form of solid state, and there will be a change of color. There will be an evolution of temperature. That is, sometimes in a chemical reaction is taking place, you have temperature rise or temperature will be lowered, and you will also sometimes there will be actually an evolution of gas. Okay, different forms of gas can also be formed because of a chemical reactions. Coming to this example where you are actually burning a magnesium ribbon with the help of a burner. Okay, so before you burn the magnesium ribbon with the help of a burner, you have to actually rub it with the help of sandpaper. So this magnesium ribbon converts it into a powdery form called as magnesium oxide. So this chemical reaction can also be returned in a word equation, that is magnesium plus oxygen gives you magnesium oxide. This equation, that is the left hand side of the equation, are called reactants and the right hand side of the equation are called the product. This arrow actually indicates the direction in which the chemical reaction has taken place. For example, that is this magnesium and oxygen will give you magnesium oxide. Okay. The simplest form of chemical reaction equations can also be written in the form of chemical formulas. You can represent magnesium like Mg, oxygen as O2, magnesium oxide as MgO. So we have seen about an example of writing a chemical reaction in the form of word equation and chemical formulae. But here comes a question whether this chemical formulae is balanced or not. Okay. What are balanced chemical equations? You know about the law of conservation of mass. That is, mass can neither be created nor be destroyed in a chemical reactions. That is actually law of conservation of mass. The total mass of elements in the reactant side should be equal to the total mass of elements in the product side. For example, you are having 2 atoms of oxygen in the reactant side. You should have 2 atoms of same oxygen in the product side also. So that is only explained here. The number of atoms of each element remains the same before and after a chemical reaction. This was the initial chemical reaction of that magnesium. If you burn magnesium and it converts into magnesium oxide. This chemical equation is called as a skeletal chemical equation, which is unbalanced in nature. So let us now see how to balance these chemical equations. I will tell you step by step procedure of balancing a chemical equation. Step 1 is to draw around boxes around each chemical formula. For example, you have to draw a box around Mg, draw a box around O2, and draw a box around MgO. Okay. The second step, you have to list out the number of atoms present in the different elements. For example, in the left hand side, this is left hand side number of atoms, and this is right hand side number of atoms. So if you can see, one atom of Mg is present here, and two atoms of O2 is present here. And if you see in the right hand side, one atom of Mg is present and one atom of O2 is present. Okay. Oxygen is present. Okay. Next step is to balance the component with maximum number of atoms. If you see here, the maximum number of atoms is actually left hand side of the equation with O having two atoms. So first we are going to balance this component only. So initially, so let me explain with a pen. Initially here in the left hand side you are having two atoms. Am I right? So in the right hand side what you are going to do is you are going to add 2, that is 2 into 1 will give you, that is one atom of O is present in the right hand side. So 2 times MgO. Okay, this is the correct form of representation. Okay, you cannot represent it as Mg2O. This is wrong. And you cannot also represent it as MgO2. This is also a wrong form of representation. Okay, you can only represent it as 2 times of MgO. What does this 2 actually represent? These 2 is not a number of atoms. It is actually the number of molecules required to complete this process. Okay, so don't confuse it as the number of atoms. Okay, so these molecules multiplied by the number of atoms will give you the total number of molecules required for the chemical reaction. Okay. Next is to balance the remaining elements. So this is balanced now. Next is if you are having 2 times MgO here, right? So what you're going to do is here in the left hand side, you initially had only 1 Mg. So now what you're going to do is 1 into 2 will give you 2 times of Mg plus O2 equal to 2 MgO. Now the chemical equation is completely balanced. That is 2 Mg plus O2 gives you 2 MgO. So we have seen how to balance a chemical equation. Sometimes you can write these chemical equations using a representation of solids, gaseous, liquid, and aqueous states. Take an example of this equation. Fe, that is iron, is in the form of solid state, H2O is in the form of gaseous state, and here also Fe3O4 is in the form of solid state, H2 is in the form of gaseous state. Okay. Don't mistake here like it is H2O, which it should be in what like liquid state, which is represented as gas here. That is because H2O is induced in the reaction in a form of steam. So only it is written like that. Okay. Okay. So one more form of representation is like you can actually add the temperature and pressures which are actually induced in the reactions to form a complete chemical reaction. Okay, so if you see here, this is actually the balanced chemical equation of photosynthesis chemical reaction. Okay, wherein sunlight actually contributes a part and chlorophyll also contributes a part to get you glucose and oxygen. Initially you're having carbon dioxide and water. Okay, in carbon dioxide in aqueous form and water in liquid form, and finally you get it in aqueous form only, that is glucose and oxygen in aqueous form. Okay, with the help of sunlight and chlorophyll. You can represent sometimes temperatures like 100 degrees, 50 degrees, or whatever degrees you are inducing there, so that you get a complete chemical equation. Okay, so let us see the summary of this discussion. That initially we saw what are chemical changes. how can you define a chemical reaction? How are you representing a chemical equation with word format and also through a chemical formulae format? And finally, we saw about balancing chemical equations. Thank you.